Hello everyone and welcome back. In this session, we are going to learn about the binary division. So without any further ado, let's get to learning. Coming to the outcome of today's session, at first we will observe the basic binary division. Thereafter, we will observe the classification of division procedures. Now coming to binary division, here also just like the other division procedures, we have the dividend which we will denote by D and we have the divisor which is V. Now if we divide D by V, as a result we will obtain the quotient denoted by Q, and along with the quotient we will also obtain the remainder denoted by R. So basically this is D, that is the dividend, and we are dividing this D by the divisor, that is V. Now we will have a quotient and the multiplication of the divisor and the quotient will be deducted from the dividend, and as a result we will obtain the remainder. Now from this we can extract this, that the value of D, that is the dividend, is actually the multiplication of V into Q, that is the divisor, multiplied with the quotient, and alongside this we need to add the remainder, where the remainder R will have the range starting from 0 to V minus 1. Now why this range? Think about this situation. Say we have both the dividend and the divisor as 3. Now in this case, we will have the quotient as 1 because 3 into 1 will give us 3. So 3 minus 3 will result in the remainder 0. So that's 0. Now suppose we have the dividend as 5 and the divisor is still 3. Now in this particular case, we will have the quotient as 1 because 3 into 1 will give us 3. And 5 minus 3 will result in the remainder 2. That is 1 less the value of the divisor V or 3. And that is the reason why the remainder can at max be V minus 1, that is 1 less than the divisor. Now let's perform a division, shall we? Say we have chosen the dividend D as 101010 in binary, which in decimal means 42. Now in case of divisor, we have chosen the value 1011, which in decimal is 11. So let's perform the division now. Observe, the divisor is of 4 bits, whereas the dividend is of 6 bits. Now if you observe the first 4 bits of the dividend, it is 1010. Now 1010 of binary is actually 10 in decimal, whereas the divisor is 1011, which in decimal is 11. So if we perform the subtraction in here, the result will be a negative one, which we don't want. So that is the reason we are going to have a 0 as quotient at the first MSB. That means we are going to consider the first 5 bits of the dividend. And now we will have the quotient as 1, which multiplied with 1011 will give us 1011. Now let's perform the subtraction. So 1 minus 1 will give us 0. Now coming to the next bits, it is 0 minus 1. Now honestly, when we perform subtraction in binary, it gets a bit tricky, isn't it? We need to borrow things. We actually need to consider quite a lot of bits. So I actually have a trick for you. And what is that? Basically, from the place where we have the subtraction 0 minus 1, we are not going to perform the subtraction of these 2 bits. Instead, from this 0, we will keep on heading towards the left until we obtain the first 1. Now once we have the 1, we will consider the entire series of bits from 1 to 0. So how many bits are here? It's 2. So we are going to subtract 0, 1 from 1, 0. Now 1, 0 in binary is actually 2 in decimal and 0, 1 is 1. So 2 minus 1 will give us the value 0, 1. So basically, we are subtracting 2 bits and that's why we will acquire the 2-bit result, right? Now once we are done with this, let's move on to the next bits. It is also 0 minus 1, so we will perform the same drill. We will consider from this 0 till this one, so we are subtracting 1 from 1, 0. That is 2 minus 1, which will give us the value 1. Now when we perform division, we are entitled to get another bit or another digit from the least significant place. So we are going to have this 0 in here. So now the result is 10100. Now these are of 5 bits and we have the divisor of 4 bits. So we can easily perform the subtraction without worrying about the result coming in negative. So again we will have the quotient as 1, which will give us 1011. So let's perform the subtraction. Observe 0 minus 1. So we are not going to perform the subtraction right away. What we will do? we will select this 0 and we will keep heading towards the left until we obtain the first one. So now we have the bit sequence 100, which is 4 in decimal. And from that, we are going to subtract 011, which is 3 in decimal. So 4 minus 3 will give us the value 1 or 001. Now what about these? 10 minus 1 will give us only 1, that is 2 minus 1 is giving us 1. So finally we are getting the remainder 1001. Let's now check whether we have the division correctly or not. So we were dividing 42 by the divisor 11. Now in case of this decimal division, we are going to have the quotient as 3, which will give us the result 33, because 3 multiplied with 11 is going to give us 33. Let's now perform the subtraction. So 42 minus 33 is actually 9. Observe, 3 in 3-bit binary is 011, correct? And 9 in 4-bit binary is 1001. So yes, if we divide the dividend 101010, that is 42, by the divisor 1011, that is 11, we are going to get the quotient, that is Q, as 11 or 3 in decimal, and the remainder we are going to obtain is 1001, that is 9 in case of decimal. So this is the binary division procedure, which is named the manual procedure or the paper and pencil method. Now coming to division, the algorithms for division can be grouped into two different classes. There are slow algorithms and there are fast algorithms. Now in case of slow algorithms, the iterative operation is subtraction. So basically we keep on doing subtraction until we get the result. And in case of fast algorithms, the iterative operation is multiplication. So basically we keep on performing multiplication until we get the result. Now coming to the slow algorithms, there are quite a few actually. Nonetheless, the popular ones are the restoring division and the non-restoring division. On the other hand, the fast algorithms include division by series expansion. Now in these cases, series like Taylor series are used for the division procedure. Apart from this, we have the Newton-Raphson division as well. Now these algorithms are not really a part of COA, rather these are to be taught in the subject numerical analysis. Now coming to the course of COA, we are supposed to observe these two algorithms, which are slow algorithms, that is the restoring division and the non-restoring division. So in this session, we first observe the basic binary division, that is the manual paper and pencil method. Thereafter, we observe the classification of division procedures. Alright people, that will be all for this session. In the next session, we are going to learn about the concept of restoring division procedure. So I hope to see you in the next one. Thank you all for watching.